Hi, my name is Arif Salvi. I'm a master's student in Shenyang Aerospace University, China. The paper I will be presenting to you today is titled as "The Novel Simulated Annealing Based Routing Algorithm in F-SDNs." The presentation outline will be as first introduction to SDN, F-SDN and SA, then proposed contributions of the algorithm, simulated results, and finally the conclusion. Moving on to introduction to SDNs. What is software-defined network and why software-defined network? Software-defined network is where the network architecture is broken down into three different layers. That is the application layer, the control layer, and the data layer. Where the application layer supports software applications, and the control layer acts as the brain of the network, and data layer obtains all the information in the environment. So as you can see here in this figure, what happens is information obtained in the data plane is fed into the control plane, where the control plane does all the logic decisions and all the necessary calculations, and then in order to execute it, they send it back, the information after processed, to the data plane, where the data plane will carry it out. And also breaking the network into three different layers makes the network more dynamic and manageable, while cost-effective and also adaptable, that enables the network to be intelligently and centrally controlled or programmed. And why use SDN? As using SDN has many advantages, while few of them are making the network directly programmable and also the network agile, meaning you can program it on the go or according to necessary situations that come across, and also centrally managed. Centrally managed meaning it gives a global view of the network, so you have a more better understanding. Moving to flying software-defined networks. Why flying software-defined networks? In UAV networks, common issues are unstable and unreliable links due to high mobility of nodes. Due to this reason, SDN was introduced to FANETs. Also, SDN eases the management of flying devices and support most form of UAV environments, that is dense environments or sparse environments. As you can see in this figure, there are drones distributed on the data layer, where the information obtained by the drones is fed into the control plane, where the control plane makes all the necessary calculations and the logic given to it. It will do all the necessary processing, and then it will forward back the information to the data layer in order to be carried out accordingly. And moving to simulated annealing. What is annealing? Actually, annealing is a physical process where a solid is heated and then gradually cooled. What happens is when you heat the solid, there is a very high movement of particles, a very random movement of particles, and while gradually cooling the temperature, what happens is the particles tend to settle at one certain place, making the solid very strong. So when that logic is applied to the routing, simulated annealing is a process where the temperature is reduced slowly, starting from a random surge at high temperature, eventually becoming greedy descent as it approaches zero temperature. An importance and method of annealing. Actually, the process of annealing When applied to discrete optimization problems, at each iteration it's able to produce two solutions, that is the current solution and the new solution, and they are compared with each other, and if the new solution is better, the current solution is being replaced by the new solution. Also, improving solutions are always accepted, while some solutions that are non-improved will sometimes be accepted in the hope of escaping the local optima in search of global optima. Also, simulated annealing is not only for discrete optimization problems, it is also been applied to continuous optimization problems. Now moving on to proposed contributions of this paper, we have three main contributions. That is a novel routing algorithm, that is by modifying the standard simulated annealing algorithm. And the second part is the modified simulated annealing algorithm considers the temporal information of UAVs to provide efficient routing. And third part of the proposed contribution is we compare the experimental results between the standard and modified algorithm. As you can see here, in modified simulated annealing algorithm, what is MSA? Actually, modified simulated annealing is where we have introduced a random temperature fluctuation to the standard simulated annealing algorithm in the hope of increasing more iterations so we can explore more search area to obtain a better solution. As you can see here in blue color, the standard simulated annealing algorithm, temperature curve, while the red line is the MSA curve, and you can see here the two temperature fluctuations we have given. And also this experiment was carried out at 200 degrees Celsius, and the reduction coefficient for this temperature curve was 0.99 as shown here. And now moving on to the next part, the main modifications of the algorithm. As you can see here, we have taken one temperature fluctuation and we have done the mathematical calculations and the expressions here. As you can see, we have expressed the delta T, that is the random temperature fluctuation increase, and the first temperature fluctuation, as also for the second, and the number of iterations. And also here, A expresses the amount in which the number of iterations increased according to the temperature fluctuation. Also, I have to say here, we have a limitation where the random temperature fluctuation does not exceed a certain point. So we have actually given a parameter where the random temperature fluctuation should be within a certain range. That is, if you take here the example, it should be below T max and above Tk. And here the y-axis represents the temperature. As for the x-axis represents the iterations, number of iterations. Now moving on to the routing algorithm. To construct the routing algorithm, we use a two-step modification on the temperature curve to create two fluctuations. And we select 2 points among the temperature curve, that is T1 and T2 respectively. Here you can see T1 is selected according to a given parameter, and also for T2, where I said earlier, it should lie within a certain range. The temperature fluctuation should be within a certain range, and that is what is being expressed here. And moving on to the path built by MSA, that is using temporal graphic information. As you can see here, we have taken a timestamp, that is a static graph information, from the temporal graphic information, and we have mapped out this graph. And what we have done here is, in this static graph, you can see it represents the nodes, where the nodes being A to J, and the cost is the numbering between the nodes. And on the left hand side, you can see the matrix, where we build the matrix using the static graph, where the values xn represent the cost of one node to another. Hence, the respective node's cost will be checked for the shortest cost connecting the next node. And how to find the cost is the time difference from one node to another during transmission. That is, end time minus the start time gives the cost of a certain path. So as you can see here, the next node of the path will be calculated and selected depending on the cost, where the delta C should be less than C new solution, cost of new solution minus cost of the current solution, where in order to accept the new solution, delta C should be less than 0. If it is higher than 0, we will move on to search a new solution. Also, the acceptance of a new node mainly depends on the number of iterations the algorithm can generate. Now moving on to the simulation results. Here we talk about the packet delivery ratio. As you can see here, in the packet delivery ratio of MSA and SA, MSA has a slight increase than SA, and this can be justified due to the additional attempts generated by the modified simulated annealing algorithm by increasing the number of iterations during the descent of the temperature curve. Also, in the moderate dense UAV environment, we can observe this figure that the packet delivery ratio has a significant increase as shown here. Also, the random temperature fluctuation will be higher in denser environments and lower in sparse environments. That is mainly due to successful attempts we can generate. Like example, if there is a dense environment, we need more number of iterations in order to reach out to several nodes to form a more better packet delivery ratio. As for sparse environments, we need a less random temperature fluctuation. Now moving on to the simulation results of end-to-end delay. Here we can observe that there is a slight increase of the delay in MSA compared to SA. This is due to the increased number of iterations, which results in more computational time. Actually, according to the simulations, the extra computational time is kept to a minimum, even though the iterations have increased. With comparison to standard SA, the increase in computational time is very insignificant. Finally, the conclusion and future work. Conclusion here in this paper, we proposed an improved version of simulated annealing routing algorithm for F-SDN in order to build the optimal routing path for relaying data packets. The routing problems concern better packet delivery ratio to enable stability when selecting nodes. Also, the second point, the simulation results verify the improvement carried out by the proposed algorithm compared with the standard algorithm. It showed that the proposed MSA algorithm can obtain better routing paths with successful packet delivery. As for our future work, We plan to investigate on the integration of SDN, unmanned aerial vehicles, and vehicular networks to support 5G and beyond. Thank you for the chance for the presentation. Have a good day.